Terrestrial ecosystems constitute a large sink in the global carbon budget, which is crucial for climate change mitigation. 22% of the geographical area of India is covered by natural terrestrial ecosystems, including forests, mangrove, savanna, scrub forest, etc., which are not only rich in biodiversity but also offer a tremendous potential of carbon sequestration, which are presently poorly understood due to a sparse network of long term in situ measurement stations aimed at continuous monitoring of the biosphere atmosphere flux exchange, which are important to quantify the INDC, that is the intended nationally determined contribution of India, as required towards our national commitment to the Paris Climate Accord. Here, we study the annual carbon cycle of a broadleaf deciduous forest in Kaziranga National Park in Northeast India, which is one of the densely forested region of India, as you can see, taken from the latest forest covered map, the Indian State Forestry Report by the Ministry of Environment, Forest and Climate Change. And this is the site picture at this Kaziranga National Park, where a 50-meter tall flux tower was erected over a surrounding canopy of almost roughly 20 meters of height. The cloudier environment during June and July, due to the presence of deep, dark, convective monsoonal clouds, hindered the penetration of photosynthetic photon flux density to the canopy, which is basically the 400 to 700 nanometer, the visible range of the incoming shortwave radiation, which actually helps the plant to do the photosynthesis. Now, due to this radiation limitation, the photosynthetic uptake is affected, which is given by the gross photosynthetic uptake or GPP. And from that, once we subtract the autotrophic, heterotrophic, and microbial respiration components, often clubbed together as TER, we get the net ecosystem exchange NEE. Now, as you can see from this figure, due to the radiation limitation, when in the months of June and July, the radiation dropped suddenly almost to the level of the radiation values in winter, it created a distinct bimodal pattern in the gross photosynthetic uptake. Although there was no major limitation at this site of water or temperature, which are also required for photosynthesis by plants. So such effects can be of potential concern in future cloudier environment where in the climate change scenario, we often predict the environment to be cloudier and hold more water vapor in the atmosphere. Now, the apparent quantum yield is a measure which actually provides the light efficiency of the ecosystem, which is basically the radiation cost paid to assimilate carbon in the plant biomass by the photosynthesis process. So, in this plot, the net ecosystem exchange that is what we directly measure, as you will find the detail in the main poster about the methodology that actually increases. That means ecosystem sequesters more carbon with more availability of light, and after that it saturates. Now, interestingly, it shows that the apparent quantum yield is maximum in the pre-monsoon season, and also the saturation NE adapted to radiation is also maximum in this season, which clearly support that the most favorable period for photosynthesis by this forest ecosystem is pre-monsoon. These values and trends need to be represented in ecosystem, earth system, and climate models for their improvement in the model performance. We have simulated the carbon cycle of KNP using a process-based model, which we are in the process of communication presently. More details regarding this work can be found in the references cited in the main poster, and I will be happy to answer your queries on our work and get your valuable feedback on this end. Thank you.